Hello, in this video we're going to work through this problem, which is find the area of triangle ABC shown below. Now, at the end of this video I'm going to go through and show you how to derive an interesting formula which allows you to find the area of any triangle. So keep that in mind at the end, and I think it's a great formula to add to your toolbox, so to speak. So with this problem, the challenge is that it's not easy to get the height of this triangle. There's a variety of ways we could do this, but one of the most common ways to do this is by dropping a perpendicular from point A to the opposite side. So we're going to drop a perpendicular straight down. And what I'm going to do is I'm going to use this length 10 as my base of the triangle, and I'm going to calculate the height h. So if we're going to use this 40-degree angle here, h would be my opposite, and 10 would be my hypotenuse. So therefore, we're going to find h using sine. So sine of 40 degrees is equal to the opposite, which is h, over the hypotenuse, which is 10. So therefore, h can be written as 10 sine 40 degrees. Now at this point, it might be tempting to get an approximate value of h, but again, it's nice in this form because it's exact. Until there's a need to get that approximate value, you're better off to leave it in that exact form, because that means when used later, it's going to introduce less error. So if we know that h is 10 sine 40 degrees, we know that the area of a triangle is equal to 1/2 the base times the height. We then know the area of this triangle is 1/2 10, there's my base 10, times my height, which is going to be 10 sine 40 degrees. And I can type this in my calculator in one go. And that's something from this problem we want to be sure we do. We want to be able to type this in one step. So 0.5 times 10 times 10 times sine of 40, and we get approximately 32.14 and units squared. We don't know what the units are in this case. Okay? So one thing you might have noticed here is, let's draw another triangle. So here's a triangle right here. And let's name this triangle A, B, C. So interestingly, let's give the sides the names. We'll call that B because opposite small b. Call this small a. Call this small c. If I wanted to find the area of this triangle, let's do the same thing we did with this previous question, but let's do it all with general case. So what I'm going to do is I'm going to assume the base is going to be b. So if I drop a perpendicular down like this, we have this value here, and we need to find h. So we can calculate h because we know that sine of a is the opposite over the hypotenuse. So the opposite is h over the hypotenuse, which in this case would be the length c. So therefore, h is equal to c sine a. And now what we're going to do is, if the area of a triangle is 1/2 the base times the height, we can substitute in directly. So the area of this triangle is 1/2 the base, which in our case we said is b, and the height is c sine a. And actually, let's write here, just so it's clear, if area. And so what we have here is we have a nice little formula to find the area of any triangle, given that we have two sides and the angle contained within. It's going to be 1/2 BC sine A. So if we have an actual concrete example here, so let's just make something up here. So here's a triangle. Actually, let's make it not look like any specific type of triangle. And I'm going to say that this is, for example, 37 degrees. Let's make this 10, we'll make this 7. What I notice is I have a side angle side case. And since I have this case, I can say that the area of this green triangle is going to be 1/2, and we take the two sides, 10 times 7, and then we multiply it by sine of 37 degrees. So this is a useful little formula that you can kind of figure out from this example. Now this by no means is an exhaustive proof, but it's a nice one to add to your toolkit. I hope this video helped.